Alright, so I think in the last stream we got this code working, which is implementing this methodology from 2015 from this paper for texture synthesis using convolutional neural nets. And so we got a variation, I mean like a version of the implementation, because we're using a different neural net architecture. And also so far we only have the implementation using a single layer. And so I think all I was going to do in this stream was, so like this is, for instance, this is a texture image off of the internet, and then this is the output of the method. So it's, you can see it kind of working. So I think what I want to do is, actually I don't know if it's going to be easy, but it'd be nice to have like a grid of images, like all, trying to approximate the same texture. From different random initializations. And yeah, so that seems like, so we'll try to implement that. And then also maybe use like different textures. I was kind of hoping to gain insight onto how this works, but I haven't really had any ideas on how to do that, so we'll just play around with it for the sheer novelty of it. Okay, so just to walk through the code we have so far, we wrote in the last stream. We're using the Keras mobilenet implementation with pre-trained weights. I think they're trained on ImageNet. And so the actual method is right here, where you begin with an initial image, which is, in our case, uniform random noise. I don't know if you should use like Gaussian random noise. I just used uniform random noise. Is that more entropic? I think it's more entropic, than Gaussian. But so anyway, so we have like a random noise image, and then what we're going to do is we're going to run the initial image through our mobilenet, and then we're going to compute the gram matrix, which is of like in this case an arbitrary layer, the 15th layer of mobilenet, and the gram matrix is the pairwise. Like you treat each filter map in a layer as a one-dimensional vector, and then you just take the dot product. So it's all pairwise dot products of feature maps in that layer, and the loss we're trying to minimize is just like the norm difference between our current image, which is the initial image, and the target image. And then we just update the initial image with the gradients that will decrease the norm, the distance between the gram matrices, between the target image and the initial image. And so that is the entire method. Now, like in the actual paper, they do other stuff, like they normalize. They do something like where they normalize the weights, and then they use different layer, or like multiple layers. and then they also normalize like the different layers by the size of those layers. So we're not doing any of that because like it doesn't matter. And so yeah, let's just see, I guess, if it works. And then, you know, maybe like try a different layer, because like we selected the 15th layer like completely arbitrarily. And you know, so try maybe the you know, I'm not even familiar with like the mobilenet. I'm just looking for ReLUs, because that typically indicates like the output of a layer. So yeah, maybe we'll also try the 56th layer. Okay, so I'm going to run this once, and then I'm going to try to set it up as a grid. So, you know, like we have multiple... I don't know if that's going to be possible, actually. Oh, right. Yeah. Yeah, the target image is, yeah, I just got it off the internet. I should, like, move this code up. Yeah. Alright, so we'll just move that code up here. So this is where we get a target texture image from the internet. And so I think I just call this target image. And okay, it should work now. Nope. Image is not defined. Where did I import that? Oh. Wow. That's pretty annoying. Okay. I think we get all our imports now. Maybe. Inputs to a layer should be tensors. Okay. Okay. Okay, so it was all of this. Wow. Gotta get all our API calls correct, or whatever. So X or M. Okay, are we good now? Oh my god. What is image? Does that need to be capitalized, or what's happening? Oh. What is this? Oh my god. I didn't know there was like 4 different dependencies. Okay, are we good now? Nope. Of course. Of course. Okay, are we good now? No. Where is it pre-processing? No, I don't need to pre-process the input. Yeah, no, I don't need to do that. Because... or do I? Actually, you might need to. Now that you think about it. Yeah, because, it's between -1 and 1. And, so yeah. Okay. So I do need to pre-process it. Okay, I think surely that is everything. Alright, we're running. Do, 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 do. Alright. Nice. That's like a fine art, you know? Okay, so let's try. Okay, so I can do. Okay, so I'm just gonna do the easiest next thing, which was I wanted to try a different layer, and I think I said 56. Like, I think it needs to be a Raylu, because otherwise, who knows what would happen. Probably nothing, but still. Alright, so 56, 56. Run both images through mobilenet. Yeah, exactly. Run them through mobilenet. Okay, and okay, so let's remember this image. Maybe. Can I like copy it? No. Yeah, we'll just remember it. Alright, so now we're hitting layer 56. Ooh. Yeah, it's because it's a different shape. And I hard-coded the shape. Because I'm lazy. 28, 28, 192. Wow. That's a big 28, 28, 192. Alrighty. So I guess like this is kind of slow. But that's okay. I think the line, yeah. So what I'm going to do next is I want a batch of initial images. So I think I'm just going to take this and make it I mean, I'm trying to figure out if it matters. I don't think it matters. Like, I could just turn this directly into a batch. So it'd be like like 4x4. So it'd be like 16. And then I think when you compute the loss here, that would still work. Gram matrix. Because of broadcasting. Although, yeah, no, that's gonna be non-trivial to figure out. Ooh, okay. Well, that looks like garbage. So, there's some information for you. It turns out if you use a lower layer, which I think makes sense because it's less processed at the lower layers. If we could, let's do layer 6. Sure. Okay, layer 6 and 112, 112, layer 6, 112 by 32. Alright, I gotta think about if I can... Oh no. What's wrong with that? Layer 6. 112, 112, 32. Layer 6. Layer 6. Ah. Alright, I gotta figure out if this will work if I just make it into a batch. I think I'll just try it. You know, just to see what happens. Okay, that didn't work very well. It did something though, you know? What was the original one I was using? I guess we lucked out because that one worked well. And yeah, we were using 15. Let's try 20. So 20, 56, 56, 144. 20, 20, and I don't think I need that. I don't know why that's there. And then 20, 20, and 56, 56, 144, I think is what it was. And then we'll do the image grid. And then there's like a new paper I need to read. Let me see if I can find it. I think it was on Reddit, maybe. Reddit.com r machine learning. Yeah, this one. I got a super resolution. Yeah, gotta read this. Okay, whoa. That's cool. So, okay, so let's try to do a grid. This is really just gonna be fighting the various APIs involved here. So it should be pretty fun. Okay, so let's just say we want... so let's say we want a grid 4x4. So our initial image, we'll say, is 16 images. And now when I call gram matrix, I want it to... Yeah, this is where it's hard. Yeah, I don't know if that's going to do what I want it to do. Let's just see what that does. Yeah, when you call gram matrix, it doesn't like it. Okay, yeah, the reshape. So, can I just maintain that dimension? And then, okay, and then what about when you do the matrix multiplication? Yeah, it doesn't like that. Oh no, it's still, oh, well, yeah, because it's the target image. Well, what if you just make the target image a grid? I mean, nobody wants to do that. But would that make things easier? Or I know there's a way to specify, like, keep the first dimension unchanged, but yeah, I don't know how to do that. I also kind of just realized, you don't need to run, you know, the target image through the, you don't need to compute that every step. Huh. I mean, that doesn't really matter, but that is wasted computation. Is it quicker now? Yeah. Okay, let's just keep this at 1 batch. Alright. It should be slightly quicker. It doesn't seem quicker. Cool. Well, it's matching those statistics pretty well. Let's get like a different image. No, I should figure out the batch thing first before I get a different image. So oh man. Yeah, it should work with broadcasting. It's just that the reshape is not gonna work, and I think you can just specify -1, and that just, I think that means keep the same dimension. I think that's cool. And okay, well, it's running. Wasn't expecting that, but cool. Of course, we're not going to be able to display it because it's a grid. Alright, so I'll just write some grid display code. If I can remember how to do that, which I probably can't. Yeah, you do. Okay, you're like fig x equals plot. I think it's subplots. And then I think you're just like, I want 4x4, and I want size to be like 12x12 maybe. And I think you just iterate through rn range 4, column in range 4. Let's see, x dot, yeah, I forgot how to do this. Alright, gotta look that up. Whoops. That's fine. What was I looking up? Mat, plot, lib, subplots. Oh, okay. Yeah. Okay, so you say ax, what was it? RC, like that maybe? Equals mshow and R. See, why is there a zero? Why is there a zero there? Or do we just need it to say like R times 4 plus C, right? That's guaranteed to work. Now this is taking way longer than I was expecting it to. I have no idea why. I do not know why this is taking this long. I might have to abort. Why are you taking so long? I'm gonna let it hit 4 minutes, and then I'm going to abort. And then I'll just run it for less steps, maybe. I'll run it for like 20 steps. It seems to be taking forever in computing the gradient, or no? Yeah? Oh, okay. Yeah, but don't... Okay, so what is the shape of the initial image? Because that's... Is this like a TensorFlow thing, or I don't even know what this is. Oh, it is a tensor, okay. So... So if I just say initial image numpy equals initial image dot numpy, and then INP, that should work. Oh no. That should be fig size, I think. Oh no. Why is it? Oh. Oh, that's not good. That is not what was supposed to happen. Well, I don't frankly know what is happening. Do I need this? That's not gonna help. Oh, come on. Huh. Okay, what is the shape of the gradients? Right. 16 Yeah, that's what it should be. Whoa, that looks really cool. I don't understand why it's only one image. Does this need to be, I mean, I don't think this matters. R times 4 plus C. I mean, I don't think that matters either. Huh. Okay, I mean, like, there are... It looks like there is data, or data, depending on your grammar. It looks like there's data in all of the images, so I don't know why... Yeah, I mean, there's definitely data in the first image. Yep, there's data there, so it should definitely be displayed. Oh, I think you do it like this. Yeah. Jesus. Okay. Much better. Now are these textures actually different from one another? Yeah, I would say they are. Okay, let's run it for like 50 steps. So this should take 15 seconds. No, that was the other thing. I don't know how long this will take. Alright, so we got grid working. And I don't know if that's like the standard way of doing a grid, but oh, you know what? I need to kill that. Yeah, I gotta kill that. Well, no, I didn't need to. I was, well... Whoops. Okay, maybe it's not gonna kill it, I guess. Hopefully not. Okay, so then get rid of that and show the grid. Probably make the grid even larger. Cool. Are these different images? I think so. It's really hard to tell. Yeah, I think they are different images. See, that kind of shows you how much the human visual system doesn't care about textures. Alright, let's do it for 100. Whoops, 100. And then I think we'll like find a different texture as well. Like I was gonna do like a synthetic texture, like a checkerboard or something, but I think just using Google is fine. Yeah, let's look at some wallpapers. Let's go wallpaper shopping. Okay, calico trellis. Oh, this one's cool. Let's try this one. That's not gonna work at all. Okay. It doesn't like my thing. Is this still running? Yep. I don't know. Yeah, I mean, okay. I mean, yeah, like, what if you do this one? I mean, like, what is this gonna do? Copy image address, hopefully. Alright, how are we doing over here, guy? Jeez. It's taking forever. Whoa, that's a big address. Is that gonna work? I don't know. How many are we doing? How many steps? 100? Oh, it's done, finally. Okay, that looks cool. And... okay. So, one observation is you're getting weird, like, pixel situations there. Can I say plot, like subplots 1 1 fig size 12 12? Is that cool? Because I don't know how else to pass the fig size. I know there's a way to do it without calling subplots, but I forgot what that is. Come on. Come on. Oh, it's so slow. What was that other thing I was looking at? No, old Reddit com r machine learning and that one and super resolution via iterative refinement. I'm just gonna read this while I'm waiting for this. Come on. Oh my god, why is it? Oh, because I reran the whole. Nah, that was stupid. I just wanted to resize the image, but no, it's fine. So make that bigger there. Yeah. Alright, so SR3. Isn't there a car called SR3? Denoising diffusion probabilistic models to conditional image generation, perform super resolution. Oops, we're done. We're done. Whoa, there's a much bigger image. Okay, very cool. Very, very cool. So you get weird pixelation, and I'm wondering if that is because I'm not clipping the image when I'm doing the gradient descent. Or... yeah. Yeah, I don't know what the cause would be. Okay, let's look at this. Are these different images? I would Yeah, I mean, they're different. Okay, so we're finally going to use a different texture. I mean, it's kind of like, it's not perfectly, you know, obviously, like, matching this texture, but, I guess, like, if you use multiple layers and the loss, that may or may not help. Okay, so we're going to try a different texture. Hopefully it doesn't do a security thingy. Cool. And, yeah, let's look at these textures some more. I think I should, like, yeah, maybe, oh no. Right, so it's like, we're generating textures here. I guess it's kind of like, I mean, it's like, what is a texture? It's something like, I mean, it seems very loosely, you know, something like where any arbitrary sub patch of the image, like, has the same statistics as any other patch, which would not be the case, like, for natural images, for instance, like, although, I mean, like, you know, it's like the concept of statistics in that sentence is not clear. Yeah, I mean, a texture is, I guess, any image where any subpatch resembles any other subpatch. And I would say that's pretty much what we have going on. So, I wonder what would happen, like, if you tried to do this, like, in an untrained neural net. I mean, wouldn't it basically do the same thing? I mean, whoa, that looks terrible. Okay, that was the target. This is what it came up with. Yeah, so I mean, like, some patches work, and some textures don't work. Okay, we'll look at this grid. Yeah. It's cool, though, because they are, like, different images, right? I mean, they're not, you know, they're not like floor tiles with artificial print, you know, where they're like the same image. Yeah, I mean, it's definitely doing something cool. There's also like a weird edge effect where like it's, I don't know what the cause of that is. Okay, let's do like one more texture. Yeah, kind of, oh, here it is. That's it. Or should I do like crocodile? Oh yeah, let's do crocodile. Alright, copy image address and paste it over right here. Alright, that's gonna be very cool. And I'm gonna go back to reading this paper. Output generation starts with pure Gaussian noise. It iteratively refines the noisy output using a UNet model trained on denoising at various noise levels. The question is this, like, if you're using this for generation, like, I mean, obviously, like, if this is what you're starting with, that's not like a, you know, noise input. I mean, can you put in like a pure noise input? I don't know. SR3 achieves a full rate close to 50%, suggesting photorealistic outputs. GANs do not exceed a full rate of 34%. I believe that. GANs produce some pretty weird outputs. Super image, single image super resolution. This process to generate high resolution image. Input or the full translation time. Conversation. Yeah, so like they're saying it's image to image, like it's not generative in the way that like a GAN maps noise to an image. At least if I'm understanding it. Okay, let's look at our crocodile. This is the target. This is the output. Not very good. Let's see it on all of the outputs. It's also possible that my implementation is... Well, no, because it worked on the other one. Okay, so I'm going to say this failed. This completely failed at generating crocodile. I mean, to be fair, this isn't, like, stationary across the image because, like, the squares turn into circles. So maybe that wasn't a good image. Let's do one more. Yeah, let's just do this one. Copy image address. This will be the last one. And then I will end the stream. Okay, I'm just going to scan this paper. Trained with the denoising objective to iteratively remove various levels of noise. What does that mean? The forward diffusion process Q, left to right, gradually adds Gaussian noise to the target image. The reverse inference process P, right to left, iteratively denoises the target image conditioned on a source image X. Source image X is not shown here. I don't know what that means. A Gaussian diffusion process. Okay, regression. SR3 bicubic reference. Yeah, I'm not, SR3. Okay, what do we got? Hopefully it worked. Well, kind of, I mean, it worked better than the other one, I guess. I mean, it's definitely doing something, right? I mean, it's... all of these images, you know, are, like, coherently part of the same thing. I was trying to think, like, if I wanted to add more layers. Probably not. Alright, yeah, so I'm gonna end the stream there. So that was kind of cool. I mean, you know, it's definitely doing something. That's pretty cool. Yeah, I think in the next stream, I don't know, we might keep doing this, or we might do like super resolution or something.